Welcome back, students. In this particular video we will talk about realization of half subtractor with NAND gates. If we compare the equations of difference and sum, we will see that equations are same. Sum equation for half adder is given as A XOR B, and the same equation is for the difference also. In our earlier videos, we have already implemented half adder with NAND gates, and there we have solved this particular equation, which is like A bar B plus AB bar, and once we have solved it, we got one certain form of equation. So I will show you that once again. So students, you can see in this particular slide, we are having this sum equation, which is A XOR B, and after a few steps, the one that is shown in the red box is the equation that we finally got. Now because the difference is also having the same equation, so we don't need to solve it. You can just follow all these steps in our previous video that we did. So I will directly write down the equation of the difference. So we can directly write that this A bar B plus AB bar will be equal to something like this. Now what about the borrow? We know that the borrow equation for a half subtractor is given by borrow equal to A bar into B. Now this A bar into B, we can again reframe this equation as B into A bar plus B bar. And using De Morgan, we know that A bar plus B bar is equal to A dot B with whole bar. And further we can also write this borrow equal to B dot AB bar, and we will include two more bars over this, like this, one and a second bar. Now what will happen with two bars? We know that from the property that A double bar is again A. So it means while we are using these two bars, these two complemented things, the output equation will be still the same. So we will note down that this is the borrow equation of half subtractor. Now using this equation 1 and equation 2, we are ready to create a logic diagram in our next slide. Now let us start implementing all this, and because we have to use NAND gates only, so we'll use first NAND gate over here, and in this NAND gate we'll be having two inputs which are A and B. So this is obviously A dot B whole bar. Now this A dot B whole bar will be given as input to two NAND gates further. So we are having two more NAND gates, and one of the inputs is A dot B bar, which is going here and here, and then this A we are giving as one of the inputs. Let us call it as NAND gate number 2, and in NAND gate number 3 we are giving B as the input, because these are two input NAND gates. So both the inputs have been given. Let us find the output of gate number 2 and 3. So it is a NAND gate, so it is like you multiply both the inputs and put a bar over it. So it will be A dot AB bar and whole bar. Similarly, output of gate 3 is B dot AB bar and whole bar. Now if you will look at this equation, you will find that we have to also do the overall multiplication of that, so that this bigger bar can also be implemented. So for that, what we need to do, we need to again combine these two, and we will give it to one more NAND gate. So this NAND gate over here will give us the difference, which will correspond to the equation that is available in this box. So with these four NAND gates, difference is done. Now we have to concentrate on the borrow. So if we will look over here, B dot AB bar with bar means if we will look at this particular thing, so this is equivalent to this part of our equation, means single bar is done. So what if we are going to pass it through the NOT gate? It means we will be using here one NOT gate, and NOT gate means single input, so we have to short the inputs. Now you see, if you are giving a NOT gate, so the logic is if this is X, then this will be X bar. So if this is B dot, as you can see here, it is B dot AB bar with bar. So what will be the X bar then? It will be B dot AB bar with double bar, and that is exactly what my borrow is. So we will write then this output that we are getting is the borrow. Now this is gate number 5. So again we have noted down, like we said in the half adder, it requires minimum number of 5 NAND gates to implement half adder. Similarly, we can say here also minimum number of NAND gates that are required to implement half subtractor is 5. This is important question for competitive exams. So that's it for today's video. In our next video, we will talk about how can we implement half subtractor using NOR gate. So thank you all and have a nice time.